right, today we're going to build a pyramid, not out of stone, but out of pure knowledge. We're going to construct this really solid foundation of SQL concepts that is absolutely going to help you crush that technical interview. So let's get into it. You know that feeling, right? That pre-interview anxiety? But here's the secret. A great SQL interview isn't just about memorizing a bunch of commands. It's really about showing them you know how to think about data in a structured way. It's about proving you can solve problems, not just, spit back answers you memorized. So, just like any good pyramid, you've got to start with a solid base. For us, that means getting the big picture, the why behind the database itself. Why is it designed this way? What's its main purpose? Answering these kinds of questions shows a much deeper level of understanding. Okay, so the first thing you absolutely have to get is this fundamental split in what a database is for. Think of OLTP as the cashier at a grocery store. It's handling quick, frequent, tiny transactions. It's all about running the business. OLAP, on the other hand, that's the analyst in the back office, looking at months of sales data to spot trends. It's about understanding the business. They're built for completely different jobs. Now, when you're building a data warehouse, you're going to run into these two designs all the time. The star schema is kind of the fan favorite. It's simple. You've got your main fact table in the middle with direct links out. This makes queries super fast and easy to write. The Snowflake schema, well, it takes things a step further by normalizing those dimensions to save space. So what's the trade-off? More joins, which usually means slower, more complicated queries. Indexes are all about one thing, and one thing only: speed. A clustered index is kind of like organizing a book's pages in physical numerical order. You can only have one of those. A non-clustered index is more like the index at the back of the book. It's a totally separate list that just points you to the right page, and you can have a bunch of these for all different topics. Imagine you have one single table with billions, and I mean billions, of sales records. Trying to find last month's sales would be an absolute nightmare. That's where partitioning comes in. It's like taking a giant axe and chopping that table into smaller monthly chunks. So now, when you ask for last month's data, the database knows to only look in that one specific, much smaller partition. It is a huge win for performance. Data is never static. It changes. A customer moves, a product gets a new name. So how do we track that? Well, type 1 is the simple way. Just overwrite the old info. Poof, history's gone. Type 2, which is way more common for analytics, creates a new row for every single change, preserving a perfect historical record. And then there's type 3, which is kind of a compromise, maybe adding a previous address column, for example. All right, we've laid the foundation. Now let's build the core of our pyramid. These are the hands-on commands, the tools you're going to use every single day to actually talk to the database, to pull, to shape, and to analyze your data. Joins are the absolute bread and butter of SQL, and picking the right one is, well, it's everything. An inner join gives you only the records that match up perfectly, but a left join? That's perfect for finding, say, all of your customers, even the ones who haven't bought anything yet. Getting this right? Yeah, it's absolutely critical. Both of these basically stack the results of two queries on top of each other. But here's the key difference. Union does all this extra work of sorting everything and getting rid of duplicates, and that makes it slower. So pro tip, if you know for a fact there are no duplicates, or you just don't care about them, always use Union All. It's such a simple tweak that can make your queries way faster. Oh, this is a classic interview question. It's a great test of how well you understand aggregation. The logic is actually really elegant. First, you group by the column where you think the duplicates are. Then you use having, which is basically a where clause but for groups, to filter for only those groups where the count is more than one. And just like that, you found your duplicates. These three commands, they all remove stuff, but man, their impact could not be more different. Think of delete as surgical removal. You're taking out specific rows. Truncate is the big red reset button that empties the entire table fast. And drop is the nuclear option. It doesn't just empty the table, it wipes the table itself from existence. So use that one with caution. Here it is, the one question you are almost guaranteed to see in some form. It's such a great test of your logic and your ability to pull together a few different SQL concepts to solve a problem. So, how would you do it? So there are two really popular ways to nail this. The old school subquery method is pretty clever. You find the max salary, and then you find the max salary that's just less than that first one.
But honestly, the window function approach using row_number is the modern, more flexible way to go. You just rank all the salaries from top to bottom, then you pick the one where the rank equals 2, or 3, or 100. It's way more scalable.
All right, we've made it, the top of our pyramid. This is where you go from someone who can just write SQL to someone who writes truly excellent, efficient SQL. These are the concepts that show you have a deep understanding of how the database really ticks.
Window functions are a total game changer. See, a normal group by squashes all your rows down into one summary line, but a window function lets you do a calculation across a window of rows while keeping all the original detail, so you can see things like a running total or a percentile rank right next to each individual record. It's incredibly powerful. Now, check this out. Look at the subtle but super critical differences here. See how they handle ties? ROW number just gives every row a unique number, no matter what. Rank gives ties the same number, but then it skips the next number in the sequence. And dense rank also gives ties the same rank, but it doesn't skip. Which one you choose depends entirely on what you're trying to do. We've all been there. You've seen this, right? A query with a subquery, nested inside another subquery, which is nested inside another one. It's a total mess. You can't read it, and when it breaks, good luck trying to figure out where the problem is. There has to be a better way. And this is that better way. Enter the CTE, or Common Table Expression. It lets you create a temporary named result set using that with clause. It just breaks a super complex problem down into logical, readable steps. Here, we define our high salary table first, then we query from it. It's clean, it's modular, and trust me, your future self will thank you for writing code this way.
You know, writing a query that works is one thing, but writing a query that's fast and efficient, that's a whole other level. These 4 keys are basically non-negotiable for any data professional. Create the right indexes. Always analyze the execution plan to find bottlenecks. Never ever use select star in production code. And partition those giant tables. And there you have it. Our pyramid of knowledge is complete. We started with a foundation of systems and structure, we built up with the core of queries and commands, and we topped it all off with those pro-level techniques that show true mastery. Each layer here supports the one right above it. So, as you're prepping for that interview, just remember this. The goal isn't just to pass a test. It's to get the skills you need to solve real-world data problems. This knowledge is your toolkit. The real question is, once you have it, what are you going to build?